Everyone, welcome to this channel. In today's video, we're going to solve a popular coding task question that you might encounter in job interviews or programming bootcamp. So, we got a problem in this document. Complete this problem using a programming language you are familiar with. In terms, do not use built-in functions such as sort, source, or index. Built-in function. That's bolted. So we're gonna fix it step by step. Give an array of consecutive integers, create function that counts the sum of all elements inside the array within O on one time. The sample array, the variable, we name it array integer, which means we're gonna addition element per element. 1, addition 2, and the next. The task is calculate the sum of a list of consecutive integers in O on one-time complexity without using any built-in functions, remember, like sum, sort, or even len, maybe. So we must return sum equal 1 addition 2 plus 3 and blah 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 until n 1 plus 2 divide 2. But instead of directly using a formula with len r like this, we assume we don't know how long the array is. So we first determine its length manually using basic iteration. This is through process avoiding built-in function because len and sum are not allowed. I need to simulate their behavior manually that let me to write a loop the count of number of elements. Manual detection, I create try this expression, then except loop to traverse the array without knowing its size. We could start with I equals 0 in initial value, then try while true. This is conditional x array in list I and this variable, then I it's auto increment 1 in every single condition. So this loop increase I until an index error occurs. So let me pass it until an index error occurs, meaning the end of the array is reached. After this, I represent the number of elements in the array. I added the condition to check if the array was empty. So with the running check conditional, if I equals 0, then return 0. Then we have to apply the arithmetic series formula. Since the array contains consecutive integers, the sum can be calculated with the formula like sum equal n divided 2 multiply parenthesis a plus b, where n is equal I, which means number of terms. Then a plus b a, it's equal array force index on plus index. Then b, it's equal array in I in 1, reduction 1, which means less element. Then it will give a it's equal array, okay, like this. Then p is equal array on I predicted 1. Then return I multiply a plus b parenthesis a plus b, then divide 2 and round up math floor. I mean, this is an integer, not decimal, not real number. Then we had to test, so we took the array integer, this one, okay, and we have to wrap it as the function that we add an indentation. Then we name it function with divide, maybe jumlah direct, and the parameter is have to array, must be array. So we have this morning with print, okay, as main function jumlah direct and the variable of denominator per data which is array inflation. We save it and we have to run. Okay, what you see, it's 55, which means we have to sum in every single elements until the last element. So to solve the problem efficiently, I have wrote a function that calculates the number of elements in the array manually by looking until an exception occurs. Then I use the arithmetic progression formula to compute the sum in constant time, which means O mean parenthesis 1, because the approach avoids all built-in function and still give an accurate result instantly, regardless of array size. Well, the second one is give an array of integers. Right now it's sorted. Create a function that returns the index of a specific element within O parenthesis log on n time, which what the hell is n? With the sample array, we give it array integer, and here we go. If we input the 102, it will expect an output of 5, which means the index of 5, 0, 1, 2, 3, 4, 5. 5 index will output is 5 because I input 102 and output 5. Okay, the task is to find the index of specific element in a sorted array using O log on n time complexity, which implies using binary search. We're not allowed to use any built-in function like index, len, or search number. So step by step thought process manual length calculation. Since we can use len, okay, let me comment it. Since we can use len, I first need to determine the length of the array manually. Let me name it with Indonesian variable myself panjang initial 0 value try and while true. The new variable n is equal x in list panjang, this panjang 0. Then panjang is auto increment with 1 except press. This loop attempts to access each index in the array when the index goes to out bounds. When the index goes to out of bounds, an index error is caught. At that point, panjang will contain the total number of elements. Setting binary search boundary. Once we know the length, we can perform binary search. Then let me using kiri and 0, and what the hell is kanan is panjang minus 1, and every panjang auto increment 1 is gonna to decrease in every try in every loop. These two variables represents the search range kiri, yes, and kanan, because we're gonna divide it in the middle, then we going to left or right, so binary search, because binary search loop is o, okay, so o log and time. Okay, the core of binary search is this loop, while kiri and kanan like this. Create new variable tengah, kiri plus kanan, and divide it 2 if x this x x x, we gonna name it the function, then return tengah value. If x yang tengah if x tengah x x x, kiri tengah plus kanan tengah auto decrement, then return. Okay, let me explain. Calculate the middle index tengah. Okay, middle index tengah, we calculate with this one. If the middle element matches the target, return the index. So if the target is greater, we move the left boundary kiri to the right. If the target is smaller, we move the right boundary kanan to the left. If the loop ends without a match, we return auto decrement 1 to indicate not found, like this. So we modify it with this function. Let me name it with depth, maybe cari, and the first parameter is x, and the second one maybe yang dicari, like this. So which means the xxx replace with the yang dicari. Yang press kiri, okay, and let me took the array integer. So we print the function cari in array integer of 102. So we run it to test the script. If this is typo, yang dicari, see 5. Okay, it's complete. It's what exactly they want. Give an array, then we import 1 and 2, the expectation output is 5. Okay, let me push the another number 45, then what the output, it should be 0 1 2. Yes, 2, because the number of index of element. Okay, okay, to solve the problem, I manually compute the the array length using try except using the block. Then I implemented a classic binary search algorithm with the query with the initial value 0, kanan and tengah pointers are efficiently narrowed down to search in O log n time. Like the brief, avoided all built-in function and achieved the goal with a purely algorithmic approach. Okay, the next is let me comment this code. Okay, read the brief. Given an array of integers unsorted, create a function that counts the number of occurrences of each element in the array. Sample array, it is array integer blah blah blah. The output expected is 5 2 times 101 times. So how many times the element of index in each output? Okay. We are given an unsorted array of integers and our task is to count the number of times each element appears in the array. We must print the result in the format like the number and count and time. Okay. We symbolic it with x. Expected output, okay, order doesn't matter. It doesn't matter with the order we unsorted. So I'm gonna create the function directly, maybe muncul because we gonna how many times muncul with the parameter x. So it's gonna easy with the lambda function, you know. Because the lambda we're gonna mapping the over each element n in the list maybe y. Okay, so let me the variable y is list. This is a list, remember, and the set. We casting the set on the list variable and we call this parameter x. We assign to this y variable, then we're gonna write list map, remember function of map. So it generates the lambda n element and we print f string and n. We're gonna x count and this it will be the represented in time with the x, maybe x capital, and this is comma after comma is the y variable like this. Okay, let me explain for the y variable. This line remove duplicate value in the array x. The set x is converts the array into a set which stores only unique values, and this list set x, because list the set x converts the set back into a list, so we can iterate for it. Now y contains only distinct elements from the original array x, because list map lambda blah blah blah. This line maps a lambda function for each element and in the list y. For each unique value and it calls x count, you see, to count how many times n appears in the original array. So we had to print in this one line comment, in this prints the value and its count in the format and x count. So because map returns a map object and this forces evaluation how the result is ignored here, only the side effect of printing method. Let's define the input array to test the function, which means list, map, and array integer. So let me print the function show the parameter x, but the argument is array integer, which is the list dynamic set array integer. Okay, like this. Oh, we got a known. So what the solution is, we're gonna unprint. So just call the function show array integer like this. See, we got the like expectation output 5 for 2 times. Yeah, so like this. And let me adding the element. It should be the 13 is gonna print out 2 times like this. Okay, 13 is 2 times. Right.